Now we can start. What is the question? Yes. Hello. What is your question? Can you hear me, Mahesh?
Yes, yes, sir.
Yeah,
Sir, I
yeah.
have
What
a
is your
doubt in
question?
the instruction encoding.
Okay. Uh, you want to explain about detail, or do you want particularly have any? Do you have any
Yes, I
specific
want
doubt,
to,
or I want to summarize again the instruction
yes,
coding?
summary. I want a summary detail. Means I have to recall.
Sure. Uh, well, I hope you can see my screen, right?
Yes, sir.
Yeah. Let's see. Let's have. I am having some kind of architecture. In this architecture, I have something called a control unit, which can able to compute provide some necessary signals like either read signal or write signal, whatever it may be. And there is some special register which we know that this is a program counter which holds the current instruction address. So if this one will keep on updating whenever I am providing a clock signal, it will keep on updating either one times or two times, I mean n times, or how many steps you want to switch to. Basically, currently we are working with a single strike cycle only, and however, we don't care about the branching option order. So, for example, I hope you know what is program counter.
Yes, sir.
You have idea? It's just holding the address of next instruction. So, at present, it is giving one instruction address, and based on that instruction, I'm passing that address to the one of the decoder, instruction decoder, okay, or instruction memory. Okay, what happened based on this instruction memory, it gives output of that particular value. Say for example, I'm passing some address to this instruction memory, I'm getting some outcode or some operation code. Okay, and that operation code only what we called as instruction encoded element. Okay,
Okay, sir.
and based on this instruction, what happened, I can decode this instruction. I just pass to the instruction decoder, which is just decode a very simple, straightforward. I can tell like it can give like source address of one, source address of two, or source address of three, or destination address. Depends on your architecture. Say for example, some of the instruction can be written with the two source address. Some of the instruction will be a single source address. Some of the instruction will be three source address, and probably everything will have single destination address. Let's say I'm having some instruction like add R1, comma R2, comma R3. If I say like this is my destination register, this is my source 1, this is my source 2. Okay. Whereas some
Okay,
of
sir.
the architecture will be looks like this: add R1, comma R2, which means that R1 is equal to R1 plus R2. This is equal to R1 equal to R1 R2 plus R3 is a process. This is the instruction. Okay, and you have question about how this instruction encoding is. You want to summarize about the instruction encoding. Let's explain about in the example like I am using a 2 byte instruction. That is, I have source 1, I have source 2, I have destination register. Like this, all the things are included in my opcode itself. I'm just passing everything in my opcode. Like for example, add R1, comma R2, comma R3 means I supposed to pass source 1, source 2, and destination, all the things, and I want to do the arithmetic operation. These are the all the control and the process to be given in the in the instruction itself. If I have such a type of architecture, this is a 3 byte. This has two register instruction set. I have two source address, one destination address, and one operation. Okay.
Okay.
Okay. Now I have one. Okay, first of all, this is when we are talking with the risk instruction set, which is reduced instruction set computing. we're going to study about in later part also. Every most of the instruction will be executed in a single cycle. It means in a single clock pulse, it has to execute all the process. For example, if I take addition, it has to complete within a single cycle. What is that computation? For example, I'm telling add r1 comma r2 comma r3. It means what operation I want to perform. I want to perform take the value of r2, take the value of r3, add it together, and store the result to the r1. So I want to take the value from R2. I want to take the value from R3 and do performance processing of these two value from R2 and R3, and I want to store in the R1 register. This is what to be happen. All this supposed to be happen within a single clock pulse. From this rising edge till the next rising edge, I want to perform this entire operation. Please think about other direction. So in normal operation, if I talk about AND here, I am feeding some input like 0 0 or some value, or 0 0 means I'll get 0 and 1 1 means I'll get 1. My question is, I'm feeding this is A line, and let us this is B line, and this is C line. I'm feeding A line here, B is like here. Okay. At that instant, I'm just looking at and I'm changing the value to this value to 1. What is the value at this particular point? Are you sure that I'm getting an answer as 1, or after some time I'll get answer as 1? What is after some time called as? This delay I called as last BDS also we have discussed. It's a propagation delay, right? If I'm thinking about a single AND gate, logic gate, I have this propagation delay means I want to fetch some data from the register 1 and register 2. Do you think that it will be happen in a short, zero idle time, or it takes some time?
It will take some time.
Yeah. So if suppose in this rising edge, I'm start to fetch some data like R1, R2, and R3, and I want to do processing arithmetic logic unit, some process, right? All these things supposed to compute, and finally I get the result R to be stored in R1. Now the result R1 is ready to write the value. So everything is ready means in this time only the next rising edge is supposed to happen. What happen if suppose my rise, if I increase my clock frequency, if I increase my clock frequency to this particular range like this, will this operation will execute or partially
I
will
think
execute?
so. I think so. No.
Exactly. So there is some critical path is there. So we need to identify that critical path, and based on that critical path, we have to set your proper clock period, all the things. Okay, that comes to the next part. I don't want to touch that part right now. Maybe later part also we can discuss. Now we can. Your question is what is instruction encoding? Let's assume that I have the registers, all the things in my this register files. Okay, register 0, register 1, 2, 3, 4, 5, 6, and 7. Okay, if I want to access this register or this register, what I want to pass so that I can take the data. For accessing any memory, what do you want? I supposed to pass the address, right? In the address
Yes, sir.
bus, I supposed to pass address. So here I have total 8 register. How many address lines should be there? For this representation, for this representation, for this accessing address, what is address? How many bits of address will be there? To notate minimum number of address, not maximum. Can
Minimum
I,
two. I think.
if I tell two address, let's say A1 and A0, it can be 00 01 10 11. So four operation only, four location only I can access. But here I have 8 locations. So how many bits are address buses or lines are required? I want location. So 000001. So this is equal to 8 locations. Am I right?
Yes, sir.
So I need 3 bit of address line to access. Access means either read or write. Okay.
Okay.
Well, so here let us. I told you the instruction. Each register required 3 address. So here I want to tell is something I want to define. Let's say this is R1. This is R. Okay, of course R0 refers to R02. Yes, 7 refers to R7. So source register R1. What is my source register with this particular instruction? What is my source register one address? This is my source register one, right? And this is my source two and destination. Am I right?
Yes.
So source two is R. Source one is R2, that is 010. Source two is 011. Destination is 001. Okay, addresses are given. Well, in this point, I want to tell that instruction encoding, I just put the structure like first put opcode, then put RS1 location, then RS2 location, then RD location. If I say like this, what is this particular bit would be equal to? Is it fine?
Yes, sir.
RS1 I mentioned, then RS2, then RD I mentioned. Then this is supposed to be opcode. How many opcode I want? I mean how many operation I have. Suppose I have only I'm going to perform only addition, subtraction. How many bits are enough?
3.
Either zero means I'll add, one means subtraction. One bit is enough, right?
Yes, yes, yes. Yes.
If suppose I'm adding one more instruction like multiplication, in order to define this state, one bit is not sufficient, so maybe I can tell 0 0 0 1 1 0. Then 1 1 is I don't care because I have not currently defined like this. If I add one more instruction, I can put that instruction here also. Now one more instruction I want to add, like I want to do like left shift. Is it possible to do with 2 bits? Totally five operations I want to perform. How many bits are required? Each operation is supposed to be coined by number, by a binary value. So if I want to mention five instruction, I need at least 3 bits. At least 3 bits. Okay.
Okay, sir.
Well, so in this case, let us omit all these things. Only four instructions I have. So two more instruction. That in the two more location, what is operation I define? Add. Add is encoded value of 0 0. Is it understandable?
Yes, sir.
Could you please give me the instruction code for subtraction R3, R4, R7? Same structure. My ISA structure is looks like opcode RS1, RS2, or destination. Uh, is my question is audible, reachable? So the same question, I'm using same ISA structure, instruction set architecture, and I want to end process this particular instruction like sub R3, R4, R7. What is my instruction encoded value? Give this given scenario.
Instruction should be R3, R4, and R7.
Yeah, my instruction
Okay.
is not that. My instruction is this one.
Okay.
Subtract R3 is equal to R4 minus
Okay.
R1. This is
Means
my
it's
source 1,
R4
source
and
2.
R7.
Yeah,
Destination is R3.
yes. Upcode is 0 1 because 0 1 I coined here. Source 1,
0 1.
source 1 is R4. R4
R4
can be
R4
addressed by R4 address is
0 1 or 1 0.
100.
Okay, 1 0.
R R2 is RS2
R7.
is R7. R7
R7
can be addressed by
as
this is
0 1
R.
0, I think.
This is my R7 address.
Ah,
What is the address will be? So I'll write the
0.
address 000, 001, 010, 011, 100. So far, like this will be 111. It is 111. Am I right? Then destination address is R3. R3 is addressed by
0 1 1.
011. So this is how they encode the value. Okay. Can you represent the same thing in hexadecimal format?
0
I
1
can
1
split it
0.
by 4 bit, and here the fourth bit is missing, so maybe I can append with zeros. Okay.
Yes.
So this will be equal to 0x 33 D. Am I right?
Yes.
What about this one? Would be add. Let me write the add instruction 00, 010, 011, 001. You have to split it up based on 4 bit. So from the rightmost bit, you have to split by 4 bit. Oh, I was wrong somewhere. Yeah, I was wrong here. So this is how we have to split it out. Here I have only 3 bits. Here I have 4 bits. Here I have another 4 bit. And this 3 bit can be extended to 4 bit by appending 0. So what is my output hexadecimal value? 0x 099. Am I right? This is 0, this is 9, this is 9. We have studied everything things in the basic decimal system. How to convert binary to decimal, hexadecimal, and so on. Are you okay?
Sir. Yes, sir.
Any other question you have?
No, sir.
Okay. Uh, well, so you got this from the suppose from this particular case. Maybe suppose the first instruction. I'm just this is my instruction memory. My first instruction is my 0 cross 099, and second instruction is 0 cross what is the value 33B, right? 33B, and so on. So if my program counter is giving some address of this point, okay, it gives output of 0 cross 99. Am I right?
Yes, sir.
And my instruction counter produce the respective value. So let's think like this. I'm going to enlarge this part alone. You just think and tell me the answer, okay? How the decoder would be looks like. So I have something called instruction memory. From the instruction memory, I'm going to pass this value to the instruction decoder. This decoder is supposed to produce some output. Some of the outputs, like this particular bit is supposed to be 3 bit, this is supposed to be 3 bit, This is supposed to be 3 bit. This is supposed to be 2 bit, and I'm feeding. Okay, maybe just give me 1 second. I'll just let me adjust this part. Yeah. I'm simply draw like this, but in here also some more extra circuit may be required. I'm just omitting all this thing, and this is my arithmetic logic unit. Okay, does this sounds okay for you? So in the arithmetic logic unit means it takes some inputs. Say in this case, two inputs are taken and do some process of arithmetic logic unit process and produce output. That output I'm feeding back to this. Not this. Sorry, I was wrong. Um, Sorry, I was mistaken. Give me 1 moment. Let me correct that. Okay. I'm simply put control in it like this. Okay. Now this is my ALU, and inside and this is my register file. It has some number of registers. Maybe I have consider like I have 8 registers. Okay, and this is some of the control signal I'm feeding from control unit, which is RD, and this is WR. Okay, and this is my RS1 address. This is my RS2 address. This is my RS3 address. Okay, so far okay. Any question so far? Any do you have any doubt in this part of diagram? I'm just blindly draw some very simple diagram I have to choose drawn here. Okay, and I'm emphasizing about what is actually happening. Previously, we have discussed something in the instruction memory, which is encoded instruction memory, the instruction set. And for example, if the instruction set is this one 0 cross 33B means it will do some kind of operation. How the computer know to process this thing means 0 cross 33B is giving output, and that is feeding to the instruction decoder. Decoder work is just spit it out the value, like this value to be given to 3-bit value to be given to here, 3-bit value to be given to this line, and 3-bit value to be given to this line, 2-bit value to be given to this line. Likewise, I'm just splitting out it. So, and I telling that this particular line is connected to the address input of RS1 register, such that whatever the address it is read here, that it take this address and go to take the respective content of the register and feed that output this line. Okay, so based on this address, that data will becomes here, and based on this address, that data comes here, and based on wait a second, yeah, I can choose magenta. Based on this address, I'll taken out that data here. Okay, is it fine?
Yes, sir.
Now, what is instruction I'm feeding here? 0 cross 33B. And I already told you ISA looks like opcode RS1, RS2, then RD value. Okay, how my instruction? What is my instruction would be? 0 cross 33B I told. So 33B means 3, 3, and B 1, 1, 0, 1. Okay. So what is my instruction looks like? My destination is R5. My source 2 is R7. Am I right? My source
Yes,
1 is R4. My opcode is 0, 1. 0, 1 means subtraction and assign this process. This is the instruction encoded value. Thus, is it okay so far?
yes, sir.
Okay. So here the encoded output, the instruction decoded output of this line is what? This is a 3-bit value. I told you. What value will be there in the blue color line from the instruction set? Could you please tell me? I told you it is holding the address of first. What are the address line? What are the address is for falling here? That is given to the first instruction. I told you. So if this address is something, and based on the address, that data will be flow here. That's what I told you. Okay, and if second address this one, and that data will be flowing in this line, and these are flowing to what is the input of arithmetic logic unit of two inputs, one operand and another operand, and this is I called as operand 1, and this is my operand 2. So the data of this one is the first data of what value? Content of here, what content is coming from? The content of address holding this line. Am I right?
Yes,
And here the content is from second address, RS2 address.
okay.
Okay. And so far I'm just telling only reading. So it means that this line will be high, this line will be low. So based on that, it is doing some kind of internal operation. Does it fine?
Yes,
And whatever the data it is flowing here, it will be writing only when the write signal is asserted. Okay, the condition is the value which is coming in this line will be written in the respective address. Which address means this address when the write signal is asserted. Is it fine?
yes, sir.
Okay. If you have any question in this part, you can raise up. I can otherwise I can proceed further.
No,
Any
sir.
question? Okay. So we want to analyze in the timing diagram basis if you like. So I'm just drawing something like this. doing the first rising edge. Okay, my program counter is set to some location, and based on that, the instruction memory is acquired that address, and based on the address provided by program counter, instruction memory is providing the output of something called this first address, which is something let us assume this address, this value. So my instruction output, encoder output, is some value I'm got from this particular moment onwards. Okay, up to this time I'm getting, let us assume, and let's take okay, let me draw like this. This total time period is some assumed to be 200 nanosecond. Okay, every 200 nanosecond it is keep on pulsating like this. Okay, and let us assume this output from the instruction decoder, it takes at least for example 30 nanosecond. So it means that a program counter feed the address, and the instruction memory also take, okay, let's consider the value also 20 nanosecond. After 20 nanosecond it will give the output. Okay, so the triggering signal is asserted, and my program counter is telling that first instruction. So from the instruction, I'm going to get the value of instruction value of 0 cross 33B after 20 nanosecond. After at 20th nanosecond, I'm getting the instruction output. Okay,
Okay.
and from this moment onwards plus 30 nanosecond, I'm getting the decoder output. It means that rs1 address I'm getting, rs2 address getting, rs3 address also I'm getting, control signal also I'm obtained. Okay, all this is happened. So here I control signal till all the things is happened. Right, let's assume that it takes about 100 nanoseconds at least to produce output. So I told the address, some address, rs1 address, rs2 address, rs3 address. Okay, and pointer will be considered, and this is take two input and one read value. So two output, two read ports, one write port, like this particular register is looks like, register file is looks like. Maybe some other register file will be have dual port, like I can have two read port and two write port also, or multiple read port and multiple write port also will be there. But I don't want to take all these things in this particular scenario. I'm just taking very simple example. I'm taking two input port or two read port, one write port. It means that I can in the register file take input only one write port. Because of one write port, it take only one input. But because of two read port, it gives output, two output. Okay.
Okay.
Now I'm telling this is a processing unit, and this is a, let's say this is a 30-bit processor. Okay, it can able to process 32-bit data at the same time. One single time it takes 32-bit data. It means that it gives output of 32-bit. So input supposed to be a 32-bit, another input also a 32-bit. That's the meaning of it. If this is a 64, inputs of two operands are 64-bit length. Right?
Yes, sir.
So each register in the register file address, totally I have 8 register, and each register are of the size of 32-bit size. Register 1 to register 7. Okay. So far okay.
Yes, sir.
Now I'm going to read the data. So at the 50th nanosecond till plus one more 100, that is totally 150th nanosecond. The total time period is 100 nanosecond. I got what? rs1 value, rs2 value. Okay, data of rs1 and rs2. Is it fine?
Yes, sir.
Okay, let's expand this one because
Sir, we have the quiz 2 is all the theory or we have to solve two more questions in quiz 2?
Problematically.
Yes,
Some
means
of
both
make it
questions, right?
problem. Sorry.
Both means the both questions, na? Theoretical
Yeah,
questions
yeah,
and
either conceptual base as well as numerical base.
okay.
Okay. Now let's continue here. So I'm getting data of this one and this one at exactly at 150th nanosecond. Okay. And I got the resultant value here, and that value is supposed to be fit here. So that what happened? I want to write back to the register R3. Otherwise, my data will be vanished. Okay. Totally, I have consumed 150 nanosecond here, and remaining I have only 50 nanosecond. Before 50 nanosecond, I want to get the RS3 value. So if it's so, what is the maximum value I supposed to be a processing time for ALU? Because this is a single cycle. I told that within the next cycle, my process is going to complete. So before this rising edge, I supposed to get my RS register 3 data, processed data. Okay. So I want to complete my arithmetic logic and from this moment onwards till sometime from this particular time onwards till some time I want to get my output of from which maybe maximum up to this time. Why I'm giving some small gap also. So mathematic logic unit may be assumed to be lesser than 15 nanoseconds, so I called as 30 nanosecond, for example. So at 1/80th nanosecond, my complete subtraction process is over, and this remaining 20 nanosecond, it is left ideal or stable. Okay, so why I need this stable time? Otherwise, what may happen? Okay, otherwise I'll just hold on this part. Let me take one old example. We have something called flip flop. A clock signal will be provided and data will be provided. Okay, if my data, let's take my clock signal is like this, and this is my pause is triggered flip flop, and I'm varying my data. Okay, let's assume like this. What is my this is a D flip flop like this. So what is my Q value here? Will get any problem in this Q value? I said there is no problem here. It gives exactly zero value and holding zero. But what is the value here? What value input I consider if it is a D input and this is my clock signal. During this S trigger, what is the data I supposed to enter? Can I take 0 or 1?
One
Why 1? Why not 0?
clock signal is showing no increasing.
Clock signal is in this triggering time. I sampled some data from this particular data inline. What data line are you supposed? Can I take this one value or this zero value? here some problem is happened. Is there any problem like setup violation? Is there is any setup violation? Yes or no?
Yes.
Setup violation is supposed to be before the edging trigger, crossing edge trigger, my data is supposed to be stable. So before rising edge, this time, okay, let me zoom it and draw in some other example. Okay, let's take my setup violation is supposed to be at least 20 nanosecond. My hold violation is supposed to be at least 5 nanosecond, and my data in is like this. Okay, during the rising edge, data is 1, okay, as well as 0, but this 1 before particular period of time still 1 only. Okay, whereas after some time it is the data is need to be stable. It means that my data is supposed to be stable exactly after the rising edge for certain period of time. Same one supposed to be holding like this, but this is not happen. So here setup time is not violation, whereas holding is not violation. Holding is violated. Okay, if my data is input is looks like this. Okay, let's talk like this. This particular time period I called as, let's say, 6 nanosecond. Okay, and this is some time about more than 20 nanosecond. Okay, in this particular edge time, rising edge of my clock signal, before the rising edge, my data is 1 and 1 for all the times. Okay, so no setup violation. And similarly, after the rising edge, some small period of time it is 1, then it is changed to 0. That small period of time is, I told you, it is 6 nanosecond. I told you, means in this case 6 nanosecond is greater than my whole time, hence no violation at all, because it is properly sampled. Am I right?
Yes, sir.
What happen if suppose instead of that, if my data is changed, let me put in different color. Instead of that, my data is changed in this time. This time, this small time, blue color time is exactly 3 nanosecond. So after rising edge, 3 nanosecond it holds the same value of 1. After 3 nanosecond, it is changed to 0. But hold is not properly sample, right? During holding time, the sampling is not stable. So it hold violation is happened. So I don't want either setup violation or hold violation. Both supposed to be discarded. Any question? This is a old topic. I'm just refreshing again. Any doubt in this hold violation and setup violation?
No, sir.
If it not so, then think about this answer. This is all called as register. Register means a collection of flip flop. So same thing like this. So if my data, if my arithmetic logic unit output data is some data value, yeah, I'm feeding here and keep on fluctuating here. Here at this time also my data is not stable. What will happen? I can't able to write the exact data. It may either violate the hold violation or setup violation. So that's why I tell you that telling you that my data is supposed to be stable before the next rising edge. Got it?
Yes, sir.
So this is a small scenario. I hope I have given the number of input data. Please just have it on mind that we are just doing all these things one by one. Okay.
Okay, sir. So I will again update.
Now,
Means
yeah, it's not too complication. Just recall it again.
okay, sir.
Maybe I am having. Let me have the simple expansion instruction decoder. What I told you, this is a block of input. It take the instruction and give output the decoder value like 3-bit RS2 value, RS1 address value, RD address value, my opcode value like this. I'm going to give output. Is it okay?
Yes, sir.
And I want you to could you please create a small IP code of instruction decoder. I'm writing the module instruction decoder, and let's take this is something like 12-bit input data, and the 12-bit, maybe I can take 11-bit input data. I'm getting output 11-bit output. That's like 3332. Okay, my model name is instruction decoder. It takes the input. I'm just giving the variable name as inst. Okay, I'm getting output like how to write 3-bit 2:0. I'm writing the label as RS1 signal, output logic 2:0, RS2, similarly RD. We can write like this because all are 3-bit. That's what I'm writing like this. Output logic 1:0, OP. Okay. So within this, I want to decode my data. What is how can I assign my value of OP equal to what is OP value? Let me write here. My instruction ISA is looks like this: opcode RS1, RS2, RD I told you, and this is my 11-bit data. Zero, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And previously I have taken an example like 0 cross 33B, which is subtraction of R. What is the R5 equal to R4, R4 minus R7 is I told the data. My instruction will be looks like 110111. Am I right? It's from okay. 1101 110 110. Unless it sounds okay. And this part is my opcode. This is my RS1. This is my RS2. This is my RD. Okay. So could you please tell me how to write my module IP code for this thing? I have this everything value in my input of variable called CINST. Right?
Yes, sir.
Instead of which value I supposed to put assign to opcode. Instruction of what are the bits I want to assign? 10 colon 9. And this is happen all the times. So I use assign. What about RS1 is equal to again
8
I'm
is
writing
to
this.
6.
Assign RS1 is equal to instruct of 8 colon 6. Okay, and RS2 is, I'm sorry, the color will be too dull. Maybe I can write in red color. Assign RS2 is equal to,
5 column 3.
yeah, similarly, assign RD is equal to,
2 column 0.
yeah, is it okay? Any doubt in this
Yes,
regard?
sir. No, sir.
So here I'm using assign keyboard. It means these are my combination logic, not a sequential logic. It doesn't depend on any clock pulse. It just happen whenever there is any input is feeding, changes happen in this particular bits. That value will be assigned immediately. Could the instruction is keep on updating? Let me go back here. Uh, yeah, I am feeding the data from the count. Where it is? Yeah, I am feeding clock pulse here only, right? And here I am not giving any clock pulse. I am not changing any instruction memory. So if the clock pulse is given, it gives the address, and based on this address, I fetch the data instruction value. Am I right? If this is pointing to this next address means, and that may be it taken up accordingly. And the change of address is happen every clock pulse. Till that clock pulse, my here the data is stationary only. Am I right? Till the next clock pulse, I'm not feeding any new address. Is it okay?
Yes, sir.
So because of that, it is read and some data, and that data is feeding to my instruction memory. So that data is also constant till the next clock pulse. Okay. So this this particular logic is valid because I'm using assign keyboard. Here I'm using blocking assignment, not non-blocking assignment. Why I'm not using non-blocking? It is not updated every clock pulse. It is updated instantly, like a normal combination logic. Okay,
Okay, sir.
is it okay or any questions? Do you have any other question regarding this particular topic?
No, sir.
So here I have written like this. So this IP code I'm written in the Verla code. Could you please tell me what is my module IP code, Verla code for this program counter module? What is my input, my program counter? What is my output? Simple example, I'm just telling you. Simple scenario, I'm telling you. My program counter is keep on updating its address from this address to next address to next address to next address to next address. Keep on like this. And every clock pulse only just keep on updating. Okay. Just try yourself, and you can come with that particular mission code in the next class.
Sir.
Okay. Yeah. there is no
Thank you, sir.
question, we can. Yeah, thank you. If I have no question, we can wind up the session.
Okay, sir. No
Okay,
question.
no question. Thank you much. Yes, Vikshaswami.
Sir, can you discuss some questions of week 5 graded assignment?
Yeah, yeah. Okay. Just give me one moment. Network is too slow. Any particular question or all the questions, ma'am?
Sir, last 4 questions.
Okay. You mean a graded assignment, right?
Yes, sir.
I can share all this screen, entire screen.
Yes, sir. 16, 17, 17,
16.
18.
Okay.
17, 18. This is very low code. Hmm.
Okay. So I can zoom it here, and here I'm doing a coding segment. This is a command for remaining question number 16 and 17. And
Hmm.
what is the first question is data path, control path. Okay. Well, in the last class also I have discussed about control path and data path. I think so. Okay. Let's compare. Okay, let's hold on here, and I'm just uh, showing this diagram. Okay. Before this one is I told you this is a program counter and there is a clock signal is provided to the program counter. Okay.
Yes, sir.
Well, here uh, if I provide a clock pulse, that clock pulse and the next before the next clock pulse, I want to prove some process. Right? Either addition means addition, subtraction means subtraction, and that is decided based on the address which is provided by program counter, and the program counter is giving some instruction, and based on that instruction and decode this process and get the data from the register file and do arithmetic logic operation and get back to the data. And between that time, I'm feeding two data here, like data 1 and data 2. I'm getting the data, the resultant data, and do some process. That process is which who is controlling my process?
Control unit.
I Yeah, it is controlling only doing some uh, state of process is same. Right?
Yes,
I
sir.
am right now on this particular state, process this. I am in the state, do this process. So control it means what is my next thing I want to do it to. So with respect to state diagram, okay, uh, here I'm having four states like A state, B state, C state, and D state, and one is state, another is a next state is a two types of structured element we are clear. One state refers to present state, and next state refers to, of course, it's a present state and next state. And state is varying at every present state is varying only at clock pulse, which I described in the block diagram, block one diagram.
Yes,
In the
sir.
block one, next state is keep on update. Its present state is keep on updating with the value of next state, and that is updated at the clock pulse only.
Okay. Hmm.
Okay. Now in this example, I am telling some result and value I have got it. Okay. And
Yes, sir.
that value will be stored in the respective register. When it will be stored in the same time, instantly or after the next clock pulse.
Yes, sir.
I have discussed here. Here I told you my result is occurred here. Okay. And it will be stable for certain period. And next rising edge is happened. Now data will be written. The data will be written on the respective register. Am I right?
Yes, sir.
So data, something I'm processed the element I'm putting into the respective register value at the rising edge. Compare when we take analogy with this particular thing, it is happen at the triggering pulse, at the clock pulse edge only. So likewise here, state is variable state is varying at the clock pulse only. So this is my data path.
Okay.
My
Okay.
state is my data path, and I'm doing some process. Okay, here also I'm doing some process, taking the data here. Here the let's take. I'm feeding some instruction. Based on that instruction, I'm feeding the data here, and based on that, it will be processed out. Similarly, another data, and based on that data, it will take the pass this variant. I call this as a data address, and passing that address to this register file, and that register will use as a respect to the bit data output. And this 3 bit is also I called as a data, and 32 bit also I called as a data. What do you mean by data then? Do you understand my question? Here I getting some from the output of the decoder, some 3-bit output, and another 3-bit output, another 3-bit output. Okay, that is I call with respect to register file. It is a data one address only, but I calling this particular data based on this particular address. I'm feeding here, and based on this address, I'm taking out some data. Okay, and that data is feeding to here, and based on this particular address this data is taken out, and it does some process, and what kind of process decided by this control logic also, and based on the control logic it is doing some process and getting output, and that data is coming here.
Yes, sir.
Okay, so what is my data path means these all are my data path, which is combination logic.
Yes, sir.
At the same moment, what operation I want to perform. For example, let's take this. So I'm feeding some. Okay, we have another. This is also a data. Please worry, I don't have to change the color. And based on instruction, this controller is giving some kind of signal to here, some kind of signal to write or read, some kind of control signal to write or write, and similarly some other extra signals. If I draw the extra complete circuit diagram, if you look on the computer architecture course, you can study about it in very much detail about it. I'm just giving a very basic illusion to you. Okay,
Yes, sir.
so this control, this particular control signal is given immediately. It is happen simultaneously, continuously. It is keep on changing.
Okay.
Okay, so this next state logic is also combination based logic. Output is also combination logic, but output is processed element. Whereas this one is telling, I want to go this process, I want to go to this state, I want to go to that state. Like this, I'm telling decision. Based
Yes.
on this decision only, my next present state going to change in the next clock pulse.
Hmm.
So this decision daycare is I called as a control logic, where output processed element of block 3 is a data path
Data path. Yeah.
and clock pulse present state is also data path.
Okay. Okay.
Got it?
Yes, sir.
I hope block 1 is state encoding. What is the state? Data path. Yeah. Block 0 is data path. Block output. Block 3 is also that. Block 1 and the block 3 are the what you call as the data path.
Data path.
Yeah.
Hmm.
And the control path is
Block zero
next
and
state.
data path. Yes, sir.
And this question, it's a sequential multiplier. We are asking to, okay, we assume that research signal is initially asserted and then deasserted. Means that I felt that these registers values are updated with the known value. It means that's an assumption I'm feeding here in the question statement itself. Okay.
Okay, sir.
Now I have three states: ideal state, multiply state, done state.
Hmm.
Okay.
Yes, sir.
And every clock pulse, when I was in ideal state, this particular clock, this process is going to happen. This is always block. In this always block, if the process trigger is happen and reset is happen, means I supposed to be in the ideal this if block is executed. If reset is not deserted, and then I'll go the else block. Is it okay?
Yes, sir.
So I initially told I in the reset signal is asserted. So in that time I was in the ideal state. That's what I given the question statement. Assume reset signal initially asserted. It means
Yes.
I was initially in the reset condition. So my ret C is equal to what? All zeros of length of width. What I'm basically here 8-bit width I am telling. So it means 16 bit of zeros I have.
Hmm.
And reg A is equal to 8 bit of zeros. Uh, reg B is equal to 8 bit of 0.
Hmm.
Okay.
Yes,
Now
sir.
reset is cleared, right? Reset is deserted. Now initially reset is asserted. I was in the state A, ideal state. So reset is deasserted. So this if block is escaped. So I want to go to the else block. In the else block, I'm just checking the state value. What state right now I am in the ideal state. In the ideal state, if my start signal is given, I supposed to do this process. What are the process means? Update reg value A is equal to reg A is equal to multiplicand value.
Reg B
Reg
is
B is equal
multiplied.
to multiplier, and reg C is again simply reassigning to zeros, all
Hmm.
zeros. Then I said go to next state. After the first clock pulse over, next clock pulse with this assigning operation, it goes to multiply state.
Hmm.
Then in the multiply state, this following process is going to happen, and after that, I go to done state, and if start is 0, I go to idle state again. So this process is continuously executing at every clock pulse. Okay. Shall I explain about the multiplier alone, multiply state alone?
Yes, sir.
Okay, that's the biggest hurdle here. Let's take this particular example. So reg A, I told I consider reg A equal to 0 cross 0 7. I call A and B. Since instead of A, I just put reg A, I have put as A, and reg B is 0 cross 0 5 as B value. Okay.
Hmm.
Now I was start signal is asserted. In this time, start signal asserted. So I will go to what state? Here reset is happened. Reset is happened means I am in the state called
Yes, sir.
ideal state. Reset is over. Next the rising edge is happened means I go to multiply state.
Yes, sir.
In this, okay, next, so x is nothing but what state?
Multiply state.
Now I am in the multiply state. So multiplication operation is going to perform. What is multiplication state? In the
That's
first, when reg b is okay, let's write the value like 0 cross 0 5s 0 0 0 0 0 1 0 1. Okay, I'm looking only this 0th bit. Okay, here reg b of 0th bit only I'm considering. If it is 1, I'll process this, otherwise I'll do the remaining process.
Yes, sir.
So it is 1. What it says? Red C is all. What is the value of C value? Red C is all zeros, 16 zeros.
Yes, sir.
Okay. And what I said? Add 16 zeros with reg A value of how many bit? What I say? This is what I. What is this particular process? Can you able to explain? What is it? I using something called concatenation. Reg A is what size? 8-bit size. 0 0 0 0 0 0 sorry 0 1 1 1. Am I right?
Yes, sir.
But can I able to add 16 bit into 8 bit? What value I supposed to hold here? No, I have no idea, right?
Yes, sir.
So I'm taking the most significant bit. Rich width is 8. No, 8 minus 1, 7th bit. The
7.
7th bit is supposed to be duplicated by 8 times. 0 0 0 0 0 0 0 0, because this 0 only I'm just duplicating like this. That process only happen here. What is let's see is equal to after the clock pulse, first clock pulse over?
Sir, if there would be 1 1 1 1 in place of 4 times 0, then
Yeah,
we'll also write
you are
same
telling
thing.
like even this number, if it is so, this most significant bit is supposed to be put here. So it means that 1 1 1 1 1 1 1 1.
Okay, okay, sir.
Okay, but here in this case it is 0. I'm
0.
putting all as 0. So my C is equal to what? 7. Am I right?
Yes, sir.
And after completion, it comes to this part. Reg A is left shifted by 1 time. Reg A is left shifted by 1 time means what is answer I may get? 0 0 0 0 0 1 1 1. Left shifted by 1 time means, is it okay?
Yes.
So it is what? It is E. Am I right?
Yes, sir.
And reg B is right shifted by 1 time and store it to B. So what happen if it is right shifted by 1 time? This data is vanished and this second bit is comes to the first bit position. Okay, like
Yes.
this. This is the final most answer. This is hence I will have the B value is 2. Am I right?
Yes, sir.
Now reg B is 0 or not? I am checking. Is it 0 or non-zero?
Non-zero.
So this condition is failed. What is the condition? What I say, if reg B is 0, state is equal to 10.
Done.
Otherwise, state is not equal to 10. So still now in what state?
It would be an ideal state.
I not go back to ideal state because my process is not over. I am in the multiple state.
Multiply state, yes, sir.
Still, I am in the multiple state only. So during the next clock pulse, this data is updated, and I will come back here. Again, the same process is happening. Okay. So the first rising gauge. In this rising gauge, my reg A, B, C is like this. Let me call as this is 0th rising gauge. This is the first rising gauge. This is 0th rising gauge time. This is first rising gauge time. My data is E2 and C is equal to 7. Okay, I'm writing here as 7. Okay,
Yes, sir.
during the next cycle, the what is the reg B is equal to? Is 2, right?
Yes, sir.
Reg B of 0th bit is not equal to 1. Hence, this process is not processed and this process will be processed. What is the value? Red GA is left shifted by one time. Red GA is left shifted by one time means this my red GA is left shifted by one time. What happens? One more zero is appending here. Am I right?
Yes, sir.
So it becomes 1C, or else alternately I can call as 16 plus 8, 24. Is it 16
Yes,
plus 8 plus 4, 28.
20.
1 0 0 0 0 1 0 0 0 1 0 0. Adding all these numbers, you get 1 1 1 0 0, right?
Hmm.
This is equal to 16, this is equal to 8, this is equal to 4. Adding up, you get 28.
Hmm.
Okay, so my data is A is become what? 28. B is become what? Right shifted by one time. Alright, so this 0 is vanished and this 1 comes here,
Hmm.
and here it is updated 0, so it becomes 1.
1.
This happened at second clock pulse. Still my B is non-zero, so I am not go to the done state. Am I right?
Yes, sir.
So during the next time I'm checking this process. My current C value is this is my current C value. Okay,
Hmm.
and reg B of 0 is still 1 because this reg B is 1. So I want to do what? C value plus reg A value. What is reg A value?
28.
28 means this number.
Hmm.
Okay, what is number? 1100 and all zeros. Okay,
Hmm.
what is adding this number? What is my C becomes? 1 1 0 carry 1 0 carry 1 0 carry 1
Yeah.
1 0 0 0 0 0 0 0 0 something. What is this number is equal to? 16 plus 3. Not 16.
32 plus
32 plus 3.
35. 35.
So C is become 35. Okay.
Hmm.
Now after this, what I said, reg value is left shift by 1. So it becomes, what is A? A is becomes, this number is 0 is turns to this value. It becomes what? It is something like 54. 56.
Uh,
Not 56. Some number I don't want to think about. Uh, 32,
56.
32 plus 16 plus 8. So
56.
answer is, are you sure?
Yes, sir.
Okay. Now, reg B is right shift by 1. Right shift by 1 means this 1 is discarded and this 1 0 will be here and there is something else. So finally, my B becomes 0, A becomes 56 and C is right now is 35.
Hmm.
This happened at third cycle. Now, reg B is 0. So what is my state?
Done.
Now it go to done state.
Hmm.
During the next cycle, fourth cycle, I am in the done state. My done signal is so far 0. If I call done, small done, so far 0, it become asserted because of this line.
Hmm.
And similarly, what I said, product is equal to red C. Red C is what value? Red C is 35. This 35 is assigned to product. I defaultly go to ideal. I say suppose not do so, but I'm just defaultly doing go to ideal. It means that I'll go in the ideal state.
Yes.
Okay,
Yes, sir.
so compare. Let's analyze here. So E 7 it becomes E. E becomes 1C. 1C becomes 3A, and 3A becomes 70, and so on. It keep on going so. Okay. After this, during this time, my done signal is 1.
Hmm. Means of the
Okay.
fourth circuit. Yes, sir.
Yeah. After this time, what state would be?
Idle.
No, the done it's when
Then,
done is hazarded, I am in the ideal. If I am the
mm,
ideal state, if the next clock pulse is provided, I go in the ideal. What is the next clock pulse? If the clock pulse is provided, I am the ideal state. My next state is the clock pulse is provided means the state becomes what?
multiply.
Yeah, that's it. Yeah, I given multiply one. You know why it changed to ideal? Let me check this one. Answer is my multiply one.
Hmm.
Okay, during this time, first clock pulse I changed to 5. During the second clock pulse I changed to 2. During third clock pulse I changed to HB is changed to. During the first clock pulse I'm 5. The next
Hmm.
clock pulse I become 2. That is here it is 2. In the Z part I am in the 1,
Hmm.
and the next part I become 0.
Hmm.
Okay, so if it is 0, then it becomes done state, and in the done state only it will become ideal state. It's supposed to be ideal only, yeah. In the
Yes,
done
sir.
state, and the clock pulse is given. In the next clock, during this triggering only, the state becomes ideal.
Hmm.
Okay,
Yes, sir.
so Z is equal to 0 cross 0 1. Okay,
Yes, sir.
are you okay? Any other question?
No, sir. Thank you, sir.
Yeah. Okay. Any other
Sir,
questions on this?
one more question.
Yeah.
So in G space, someone said that you will start discussing about uses. So when will that start?
Yours is actually yes. The last class, Ashutosh is taken, and he is asked. He told that he's going to continue the next coming Saturday also.
Okay, okay. Like he
From
asked the
Sunday,
time, but there was no session at that time.
I think he changed the time to Sunday due to his emergency. He changed to Sunday, and he shared that updated in the academic calendar also. I hope is there any problem in the receiving of academic updation?
Maybe so.
Could you please check the calendar all the times if necessary? It would be good because we just swap if necessary. We'll just change the time and update in the calendar itself. And I asked this Optim to inform also. Hope it is shared in the G space as well as in the announcement also. If not, please tell me. I can inform to the operation to take in serious.
Okay, sir. Okay.
Okay. I
Yes, sir.
hope that tomorrow is the last day to submit it for week 3
Programs.
weekly assignment, weekly programming in the theory part, in the theory portal, practice assignment 3, and in the lab portal, weekly assignment 3, I think so.
Yes, sir.
Both are at the same time and date. So try to complete, and I'm sure that most of the people, I am not sure why the people are not eligible. I don't know. Please consider this one very seriously. Lab part is we are taking it serious. Like if you are eligible, only allowing to appear in the exam. Otherwise, we are not sure. So those who are participating and please submit your assignment properly.
Yes, sir.
And I hope most of the people are not dripping on. I just want to ask you, you guys, please give me freely answer me. Now, how do you think about the peer reviews? You get any enrichment from the peer reviews? The feedback given by the peer members.
So I think like students only open the PDF and like write that. Like nobody's checked them seriously. So it's
Okay.
like um
So what kind
no,
of improvement we can improve, we can add on it?
sir. I was thinking that if like you all are like having time and you can check, that would be more good. Or any
Okay.
TA would be
It's,
there because like in
uh,
maths we have TAs and they tell like what are the mistakes in the particular question. So in peer review we don't know that what is the mistake we are having
I
while.
saw a few randomly chosen some of the papers I'm checking. So I get some answers like they have putting like question number and option on. I'm asking for the reason, but they are putting option. If it's so, there is no need for writing and submit that one waste because writing option is not a valid feedback. You have to tell me that why I chosen the answer. If you have some MCQ type question, if it is NAT means also we are solving some people are solving, but I don't know why people. Even I informed the students also. Please don't write the answer option alone. Please write why you have chosen that option also, but some people still submitting like that way. And one more point, we can also start doing some evaluation randomly only, but not 100% because about 130 plus people are there in this course itself. And within the next week, if I want to clarify all the things, I hope it will be too complicated going for us because we also have some other committed works is pending for us. I need to complete that part also. So I just have one. Because of that, I'm not telling this statement, and I'm telling why this peer is supporting to you is if you do if some people peer review members is giving some feed comments on your questions or some your answers what you have written. If it is viable, just accept it. If it is not acceptable, means please feel to give the statement like why give these answers,
So
why
some
you are
people are
marking.
like randomly submitting the PDF as they write options and not all the questions answer. Like in formality they complete just like this only. I got some
Yeah, and
PDF.
yeah, what about the peer peer? If suppose for you, for your case, as I previously, what you said is what I expected. Like the other thing is, some peer students, peer reviews you are received, right? And you accept that all the peer comments given by the peer review members,
Yes,
or
sir.
any controversy is there.
Some are there, some PDFs I got.
If suppose some people telling you that your paper is not answerable, the answers are not correct, and statements are incorrect, and this is a statement you have to show, and but in such a case, if such a things are true means okay. If it is faulty statement by randomly just guessing, they just blindly they are writing something like this. Your answers are wrong. It's
So
incorrect.
like in
Uh,
graded
and
assignment
you
5 only, my 4 questions were wrong, but in peer review, somebody wrote that all are correct and everything is correct.
then you have to see, would you like to accept this one, because you know that you are telling that I have not answered this question, but they are telling that answers are correct.
Yes,
It's a
sir.
wrong thing, right? Please,
Yes, sir.
if you put this question, what happened, the peer people will be do their work sincerely, and I expected peer members to give their understanding. Their comments give some understanding, and based on that comments, if the comments is not acceptable, what you can do means just put that comments in the discussion forum, so that I'm ready to answer in that part, because most of the time I can spend that there only.
Okay.
If the commands are, this is the command I'm getting for this question, is it acceptable or not acceptable? Yeah, I feel this not valid statement means tell in that particular discussion forum, and if I accept that, and you can give return back the state peer commands to the reviewers, so that they can correct themselves also, because of their misunderstanding only they are giving these answers.
Hmm. Okay, sir. I'll do
So let's
this.
grow all, because I'm also want to grow, you also want to grow, right?
Hmm.
Of
Yes,
course,
sir.
everybody wants to grow.
Mm.
So your comments you makes me to grow. Similarly, my comment makes to you to grow. Start learning.
Mm. Yes, sir.
Okay.
Mm.
And if it is wrong, means please tell straight away tell that this is wrong. Return back them. Let them properly do the reviews in the next moment or not, so that I can able to identify your statement. If you are telling that this is a wrong command, I can look on that particular thing and I can do the proper penalty for them, so that the next time they can do the right order.
Yes, sir.
Okay.
So, like, we don't know now who has done the peer review of our assignment, so I'll
That
just.
no, this is a blind review. But you give this command. My pair commands like this. I am not accepting this command. Just you can you receive the commands, right? You can
Yes, sir.
claim to them. Then higher up people will look on it. Why they are she is rising or some return back. Let's look at the statement. Then I can
Mm.
have see instead of bunch of answer script, I can simply filter out very simple narrow down, right? I can pick only very few numbers. I can easily sort out the problems easily. That's what I'm doing.
Okay, sir. Okay. I'll do this on next time.
Okay,
Mm. Yes,
next
sir.
time let's do it. And I hope everybody. Is there any other problem? Please feel to free to answer, raise the question in the forum itself as G space also. Very necessary thing you put in the G space. Otherwise, most of the technical part is putting in the discussion forum. Again, I'm
Okay,
requesting.
okay,
I
sir.
think people are not using discussion forum very properly, other than the first batch. Second batch numbers are very less in. They are mostly using easy with the G space. I hope this is very easy and convenient, but all the time it's not convenient. That's what I'm telling you. Please use discussion forum.
Okay, okay, sir.
Okay.
Mm.
Thank you.
Thank you, sir.
Shall we wind up?
Yes, sir.
Okay.